So let's say we're trying to find the area of a triangle, and we know the standard formula to find the area, okay, which is equal to half base multiplied by height, okay, where b is the base down here, and we've got the height of the triangle, which is again perpendicular to the base, right? However, let's think about if we weren't given the height, and say we were given an angle here. We'll call this angle C. Okay, I might call this A. I've got B there, and I've got length C. Okay, and let's say we had to find this without, say if we didn't know what H was. Okay, so what I'll do is I'll actually look at this and try to make a new area equation. So I'll put my H back there for now. So what I'll do is I'll use a bit of trig, right? When I use a bit of trig, I find that if I use opposite over hypotenuse, that becomes saw. So I can use sine theta. So I'll go, actually sine of C would equal the opposite, which is H, over A. And if I take the A to the other side, so I multiply both sides by A, okay, I'll get A sine angle C equals H. And what I could do is I could replace this H with this. So I'll go and write this as area of a triangle equals half B multiplied, now I'll put a bracket there, A sine angle C. Alright, but B is the base, so B is still labeled there. And I can rewrite that as area equals half AB sine C. Now you'll see most of this kind of formula in your textbooks or workbook quite a lot. Sometimes they may write it as A equals half AB sine theta. Okay, there's many versions of it. Some people write it, I mean, if you are thinking about, you can write it as half BC sine A as well. Okay, so there's many different versions of it. But the key idea is, if I had to draw another triangle up, okay, if I draw another triangle up, the key idea is if this is your angle, then you're looking at these lengths over here, not the length that is opposite it. So this length opposite it we don't consider. We only look at the lengths that are alongside that angle. Okay, so this was C. Okay, so therefore it's AB, which are the two sides, and angle C. We don't care about the opposite length. Okay, and that's how we can find the area of a triangle without using half base times height, say if we weren't given the height. So let's look at an example, okay, and how we can solve this. So let's just add a triangle, and I'll try to draw one. A rough triangle. Remember, this is not to scale. And let's just say this was 15 centimeters, and this is 8 centimeters, and this angle over here will make it 112 degrees. And we were told to find the area of this triangle. Okay, again, I'll write my formula down. So A equals half AB sine angle C. And I'll go down and label. So I can make this A, I'll make this B, and I'll make this capital C. And then I'll just go down and fill in the blanks, or fill in the variables. So I've got half, I'll replace A with 8, I'll replace B with 15, sine, and replace C with 112. And I'll put this in my calculator. Okay, so I've got, I'll use 0.5 multiplied by 8 times 15, sine 112, close that bracket to close another bracket, because I open 2, and therefore the area is 55.63. So area equals 55.63 centimeters squared. So I've added my units in there as well. And that is how we go about finding the area if we weren't given the height, and using this formula right here. Cool.